Welcome to David Alexander Maths Tuition. This is chapter 2e on functions. Okay, using the functions f of x is 7x take 2 and the g of x is 2x plus 5, find the values of the f of 10 and g of 3. So all this means is 10 is our input. So we're putting this into this function, so that's going to be 7 lots of 10, take away 2, so 70 take 2, which is 68. The g of 3, that means 2 lots of 3 plus 5, 6 plus 5, so that is 11. Okay, here's a harder example. The function f of x is defined by f of x is x squared minus x minus 12. Given that the f of k is 8, find two possible values for k. So that means we're putting k into the function, so that means k will be squared, and then we'll subtract k and we'll take away 12. We're not putting 8 into the function, this equals 8, so k squared minus k minus 12 equals 8. So we've got a quadratic equation that equals 8, so if I subtract 8 from both sides it will then equal 0, and I can hopefully factorise and solve it. Factors of negative 20 that add up to negative 1 are, it's not nx, it's a k, so let's try that again. So that's going to be k take away 5, k plus 4 equals 0. Let's just double check. Minus 5 plus 4 is minus 1. Minus 5 times positive 4 is negative 20. Good. So our solutions, or the two possible values for k, are positive 5 and negative 4. Find all the roots of the following functions. Well, roots is where the function equals 0. So 3x take away 10 equals 0. That means 3x must equal positive 10. So x is 10 over 3. So 10 thirds is the root of the function. Here we can, we just need to make it equal 0. So x squared plus 12x plus 27 equals 0. So that will be x plus 9x plus 3 equals 0. So the roots are negative 9 and negative 3. X squared minus 49, we need to make it equal 0. So that's going to be x plus 7 x minus 7 equals 0, so therefore the roots are negative 7 and positive 7. Okay, here on this last one, this one's actually quite easy. We know x plus 7, x minus 3 equals 0. So from the x minus 3 we get the root of positive 3. From x plus 7 we get the root of negative 7, and from this floating x that is a root of 0. Remember that when we multiply these three things together we're getting 0, and if the product of three things is 0, one of the things must be 0. If x minus 3 is 0, then that means x must be positive 3. If x plus 7 equals 0, then x must be negative 7, or x is just the 0 itself. Okay, the functions f and g are given by blah-de-blah-de-blah. So find the two values of x for which the f of x equals the g of x. Well, this is nice and easy really. All we need to do is make the f of x, just write it out algebraically. This is the f of x and this is the g of x. Okay, so we've got an x squared here, so to solve it I need to make it equal 0. I don't want it equaling negative x squared plus x plus 8, so I'm going to add an x squared to both sides. I'm going to subtract an x from both sides, and I'm going to subtract 8 from both sides. So the only way I'm getting a 2x squared is a 2x and an x. And factors of 12 are 12 and 1, and I know that if I put the 12 here, that's going to be doubled to give me 24, and the 1 here will take that down to 23. Now if I want negative 23, that's going to be my minus 24 plus 1 minus 23. There we go. So 2x plus 1, x minus 12 is 0, so the two values are x is positive 12 and x is minus 1/2. The function f is defined as x squared minus 2x plus 8. Okay, so what we are going to do is, this is asking us to complete the square. So that is going to be x minus 1 all squared minus 1 plus 8. So x minus 1 squared plus 7. Okay, so that is in the form of x plus a squared plus b, where a is -1. Even though it says plus a, quite often it could be negative, so don't worry about that. And b is +7. So why is this function greater than 0 for all values of x? Okay, well, let's think about the turning point. The turning point would be +1, +7. So if I were to do a sketch, we know that a quadratic is a U-shaped curve, and if it turns around at 1, 7, so let's say, well, this is 1, this is 7. There we go, fairly poor drawing really. The function of x is always greater than 0 because it's got a minimum value of 7, because it turns around at 1, 7. Okay, so that is why, well, that is the minimum value of the function. The minimum value of the function is this here. Okay, so that is the minimum value of the function of x, is the minimum y value. Find all roots of the following functions. Okay, so we know that the roots is when the function equals 0, so that's x to the 4 minus 13x squared plus 36 equals 0. Now this is a disguised quadratic, so this will factorise to an x squared plus or minus something and another x squared plus or minus something. X squared times x squared gives me the x to the power of 4. I'm looking for factors of 36 that will give me 13. So 36 and 1, that's no good. 18 and 2, that's no good. 3 and 12, no, that's no good. So how about 9 and 4? Okay, that works. 9 and 4. And because it's plus 36, the signs must be the same. The only way to get minus 13 is to do minus 9x squared in the inside and minus 4x squared on the outside. So what this means is that x squared minus 9 equals 0, in which case x squared is 9, and from this bracket x squared is positive 4, so therefore x is plus or minus 3 and x is plus or minus 2. So there are well, 4 roots: plus or minus, plus 3, minus 3, plus 2 and minus 2. Okay, so the hard thing with this one is recognising that this is a disguised quadratic. Because this is half of this, well, it's not half of it, well, because 2 is half of 4, well, that's how I see it anyway. So here's another example. X to the 6 plus 28x cubed plus 27, another disguised quadratic, so that's x cubed and an x cubed. That will give me the x to the 6 and will also give me a certain number of x cubeds. Factors of 27, 27 and 1, so plus 27 plus 1 equals 0, in which case x cubed is negative 27 and x cubed is negative 1, meaning that x is minus 3 and x is minus 1. Only two roots there. Okay, so for this last one, again, this is a bit of a problematic one. So remember, this is x to the power of 1. Let me just write this out again. So this is x to the power of 1 plus 8 root x. That is x to the power of 1/2 plus 15. So again, because this power is half of this one, this one can be written as x to the 1/2 and another x to the half. X to the half times x to the half gives me an x, and if I chuck some numbers inside the brackets, that will give me a certain number of ax, or a certain number of x to the halves. So factors of 15 that give me 8 are 5 and 3. So x to the half plus 5, x to the half plus 3 equals 0. So therefore x to the 1/2 is minus 5 and x to the 1/2 is minus 3. If the square root of x is negative 5, then that means x is minus 5 squared, so 25. And if the square root of x is negative 3, then x is negative 3 squared, 9. So these ones are quite tricky, not easy to spot, but I suppose the key thing is recognising that 2 is half of 4, 3 is half of 6, and this is a half. A half is obviously half of 1, and turning it into two double brackets.